In this video, we're starting our discussion about OSPF with IPv6. Here's part 1. So we're used to our traditional OSPF version 2. We use it with our IPv4 networks. We've been using it for a while. Some updates needed to be made in order for OSPF to work with IPv6. Thus, OSPF version 3 or OSPF v3 was created. It's our version for or used or created to handle IPv6. We have two ways of configuring OSPF for IPv6, what we refer to as the traditional way, using the IPv6 router OSPF command. And then we have our new, quote-unquote, new way, using the router OSPF v3 command. In this first video here, we're just going to go over the traditional way of configuring it. And then in the next series or the next sections, we'll look at configuring it the new way for IPv6 and then also configuring it the new way for IPv4. We can have both address families working at the same time under or using OSPF v3. OSPF v3 still uses the 32-bit router ID written like an IP address, right? This is important to us because if the only thing our OSPF network is running or that router is running is IPv6, you have to configure a router ID, right? Because it tries to find its router ID first through, if you've configured one, if you've manually configured one, then it will look at the highest IPv4 loopback interface, and then it'll look at it will look for the highest IPv4 active or physically active interface. And if there's no IPv4 on there, we have to have a router ID. If we don't have a router ID, the process will never start up. One thing sort of new to OSPF v3 is our two LSA types, type 8 and type 9. Type 8 is the link LSA, which sends link local addresses to other routers on the link and IPv6 prefixes associated with that link. Type 9 are intra-area prefix LSAs. They contain the prefixes for transit and stub networks and their link state IDs. So first, let's look at our traditional commands for configuring OSPF or for IPv6. We first have to enable IPv6 routing using the IPv6 unicast routing command. Then we'll create the OSPF process using the IPv6 router OSPF and then like a process number, process ID. We need to configure the router ID in our instance for sure. Remember, it's optional if you have IPv4 running and you have IPv4 addresses on that router. But since we're not going to, we have to make sure that we configure the router ID using the router ID command. And then lastly, we need to enable OSPF on the interfaces that we want to participate in OSPF routing using the IPv6 OSPF, then the process number, the area, and then the area number command. So here's our first topology. I already have all of the interface IP addresses configured on each of the interfaces. So everything is connected. And again, I just kind of got in the habit of denoting my loopback addresses or putting them in there so that I have more networks to display for you rather than connecting a bunch of devices. So here is not necessarily a bunch of computers. It's really a loopback interface with these addresses on them. They each have, so I have loopback 0, loopback 1, and loopback 2. And then over here I've just denoted it as a loopback. And my loopback 0 over here, that's its address. Okay. What will happen is we configure routing correctly in branch 1. We should see all its directly connected networks. Then we should also see the FD012 network and the FD014 network. And then in branch 2, I would see all of these as OSPF networks. And then this one here would be directly connected. So this is what our topology looks like. Let me erase the ink from the slide and give you a second. So here's what we're working with. Two areas, area 0 and area 1. HQ will be our area border router between 0 and 1. So let's go ahead and configure. Like I said, IPv6 addresses are already configured. I'll go ahead and I'm going to, actually, no, I configured IPv6 addresses everywhere. I configured routing, so routing is done, IPv6 routing. So the routing is done here. and routing is done here. So this has been configured with IPv6 routing. This has been configured with our IPv6 routing. This way you don't have to go through it repeatedly. You see the commands once. If you want to go back through the video, of course you can. And now we are just going to go down and configure IPv6 on branch 1, and then go ahead and we will activate. I think first we'll activate two of the four interfaces for IPv6 so that we can see over in branch 2, in fact, the only of these interfaces that will participate are the ones that we've activated for IPv6, and then we'll go ahead and we'll enable the other two for IPv6. In order for this to work, of course, the first one we have to configure for IPv6 or to participate in it would be our physical link so that it can announce and work with OSPF on both sides. So let's go ahead and do that. Okay, so I brought my branch 1 console over, and remember I said I've already configured HQ in branch 2. So all we're going to do is, as this demo, is just go through the configuration of IPv6 routing with OSPF the traditional way, or what we refer to as the traditional way. And then if you are having trouble remembering the command or you need to pause to see what's going on, you certainly can. So IPv6, first thing we have to do, is enable unicast routing, right? IPv6 unicast routing. And then we'll create the OSPF process, IPv6, router, OSPF, and then the process number we'll just use 1. Remember, we have to create a router ID because we have no IPv4 addresses on here, so we will do router ID. I just did a tab completion. Since this is my first router, he'll be 1.1.1. This is router ID. And we can go ahead and exit back one, and we'll go into our interfaces. We have to do gig, I should say, we go into the interfaces we want to activate for IPv6. So let's do gig 0/1, and the command to activate it is IPv6 OSPF 1, and this guy is in area, area 0. And I misspelled OSPF again. I do it a lot. OSPF area 0. And then I'm going to go ahead and you can see that our adjacency came up right away with our neighbors 222. So I did router IDs of basically 1, 2, 3 if you went across, the part of a triangle. So branch 1's router ID is 1111. HQ's is 2222, and then branch 2 is 3333. I'm sorry, 3333. Yeah, that was correct. Ooh. So we have created branch 1 and HQ have now formed their neighbor relationship pretty quickly. So that's good. Now let's go into loopback 0, and we'll go ahead and configure him for the process to participate in OSPF. IPv6 OSPF 1 area 0. Wow, it spelled it again, or misspelled it again. There we go. And I just like to clean up put end. You don't necessarily have to. Now let's go over to branch 2 and just double check that we in fact do see those routes. Remember, we only have IPv6 on here, and that's what we're looking for. So let's do a show IPv6 route. And what do we see? We see 1.1, which is branch 1, is what branch 1 is advertising. Right? HQ is also advertising 1.1 because it would be directly connected to branch. I'm sorry, 1.1 is what branch 1 is advertising. HQ is also advertising it within OSPF, or is letting it participate in OSPF. And then we also have our loopback address that's on branch 1 participating in OSPF. And he does show up as an OSPF network, or an OSPF route. The others are directly connected. And notice too that our other loopbacks, we have 2 other loopbacks configured for IPv6 on branch 1. They're not being advertised here because we didn't tell them to be enabled for OSPF. So let's go back and do that and then make sure that they come up and verify that in fact they're there. So if we go back and we'll do, and so what's the command? In LO1, what's the command to go ahead and let loopback 0 participate in OSPF? Right, IPv6, OSPF, the process number and the area it's in. We'll do the same thing for loopback 2 and LO2, IPv6, OSPF, just did it twice, process 1, area 0. Let's go ahead and see if branch 2 has been updated yet. Sure it has. So now we've got our 1.1 link, which is our link going through HQ to get to branch, our link between HQ and branch 1. We've got our loopback 0 that's on branch 1, our loopback 1 that's on branch 1, and our loopback address, our loopback 2 address that's on branch 1. So we're fully converged OSPF v3 for IPv6. Now let's just verify a few things. I'm going to stay on, I'll stay here. Let's go to HQ to do that. Okay. So first things first, let's do a show. Let's look at just OSPF routes. So show IPv6 route OSPF. Now we see all of the only OSPF routes here. One thing I also want you to notice is that just like we did in EIGRP, OSPF also uses its link local address in its routing table. So instead of saying, okay, well, I can get to FD013::1 by going to or via FD01:3::1, instead it uses the link local address. Same thing down, I mean, it's the same thing for both, but link local addresses are required for OSPF IPv6. And there are instances in which you may need to, you have to specifically use that. So if you're doing a non-broadcast multi-access network, you have to advertise the neighbor on at least one side or configure the neighbor on at least one side. You'll have to use the link local address in there. So you use the neighbor command, IPv6 OSPF neighbor, and then you would put in the FE80, which is the link local address in there. Because OSPF for IPv6 uses that as the way to get across that link or to get to that route. Let's go ahead and do show IPv6 neighbors. And again, notice link local addresses are being used for our neighbor relationships. That's also, let's be real specific to OSPF. So let's do a show IPv6 OSPF neighbor. When I'm real specific to OSPF, I'm going to see real specific OSPF information. I mainly just wanted to see that we're using link local addresses here. Now, if we look at HQ, this maybe look a little more familiar to us that we're used to looking at more often. We have the neighbor 111, which is branch 1, and our neighbor 3333, which is branch 2, and HQ is the guy in the middle, right? So when I just use the show IPv6 neighbors command, what I see is the IPv6 link local address for our neighbors. If I do a show IPv6 OSPF neighbor, I get the OSPF neighbor ID or router ID. Router ID is the neighbor ID we configured, correct? Because if you notice FE80, this guy here, same as this guy up here. So we're getting to this loopback that is on branch 1 by going to the neighbor, by going to branch 1 on gig 01. If I just do the show IPv6 neighbors, then what I get is the IPv6 address of my 2 neighbors as my information. If I do the show IPv6 OSPF neighbor, I get the neighbor ID, which is a little more in this case recognizable, although you can configure IPv6 link local addresses rather than having them automatically discovered or figured out. So let's go back to our topology again just to try to, I don't know, just double check. So we've got everything working correctly. I just want to clarify because you guys didn't get to see this side of my configuration. I only did the one side. Otherwise this video would be a lot longer. That the router ID for HQ And the router ID for branch is 333, which is like what I kind of explained in my discussion, but then I realized, maybe we can't really visualize that. So then what happens is, if I did the show IPv6 neighbors, uses the link local address. If I do a show IPv6 OSPF neighbors, I get that router ID. So I think that's it. We could also do a show IPv6 OSPF database. We could also do a show IPv6 protocols. Suppose we could go back through real quick. Let's do a show IPv6 protocols. Here we'll see IPv6 routing protocol OSPF1. The router ID in this router is the 4 2s. This is an area border router, which is kind of cool. You didn't really notice that before, right? It's the border router between 0 and 1. Let's go back to R1. Show IPv6 protocols. Here again, routing protocol, router ID. It's not signified as an area border router because it's not. All of its interfaces are in area 0. We show all of our interfaces in OSPF, and I'm just going through some stuff, but one of the things we want to notice is our link local address on our loopback 0. Automatically, because I didn't configure it, automatically found out by the router or calculated. But here's the link local address used in our neighbors. The designated router in this topology is actually HQ, so designated router ID. Remember 22222 is HQ. So anyway, just some information to get. The big thing is to remember, how do we configure it? And here's commands, traditional commands, and then just some specific things, like we have 2 ways of configuring it. Don't forget that the router ID is still 32 bits, and we have a couple new, quote-unquote, new LSA types. And I think that's it.